You draw A, B, C. Why are they all capital? They're vertexes. Then you label them A, B, C. Why are they all small letters? Because they're sides. Why is this one C? Because it's opposite big C. Got it? Good. Now, right now, you are all indeed capable of doing trig on this question if and only if we add this vertical line. Now, up until now, we have been calling this line, we would have called it the height of this triangle, yes? I do not wish to call it the height, because of course, if we call it the height, that's going to mean we would probably label it with an H, right? But we've already been labeling things in trig with an H, the hypotenuse. So I do not wish to label this H. I'm going to label a letter that we never use. I'm going to call it Q. Is everybody cool with that? You could have called it any letter you wanted, but you wouldn't use A, B, or C. I wouldn't use O because we've got opposite. I wouldn't use H because we've got hypotenuse. So I'm going to use Q. Is everybody okay with that? Now, once I do that, that now sets up two different triangles, yes? So I'm going to go ahead and I'm going to name this point right here D. So now I can talk about the two different triangles separately, yes? I have triangle ADB and I have triangle ADC. Is everybody cool? Yes? Okay. Q is what we call an altitude. And it is simply that, a line from the highest point of the triangle down to the bottom, and I'm making air quotes for people that are not here, to the bottom of the triangle, and it is perpendicular. So it is an altitude, and AD is perpendicular to BC. Everybody with me? That's what makes an altitude. Is everybody cool? Okay. Now, is BD equal to CD necessarily? No. Okay? They are not cutting this. This altitude does not necessarily cut a triangle in half. All right? Now, don't write this down, but what if it was this? A, B, C. Is that altitude cutting the triangle in half? Yes. Why? Because A and B are the same. Or AB and AC are the same. Everyone's cool with that? Okay. This is a big mistake kids make. They cut it, they put in the altitude, and then they think these two are the same. They are not necessarily the same. Everybody cool? Okay. So I'm going to erase that. Delete. Okay. All right. So we're all happy with that, yeah? Now, in triangle ABD, if I was just dealing with this triangle over here, then we would know some stuff about it, wouldn't we? We would know all our sine, cos, and tans, yes? So I'm going to specifically pick on, because we're doing the sine law, I'm going to use sines right now. What is the sine of B? Q and wow. Yes, it is Q and little c because sine is opposite over hypotenuse, right? So sine of B is Q over C. Is everybody cool with that? Everyone is good? Okay. What then is sine C? Here is C. What is sine C? Q over B. Correct? Is everybody with me? All right. Now, what do you see that is the same in both of those expressions we just wrote? Q is in both, yes? All right. So, what would we do to solve for Q in red? Solving for Q means we get Q isolated. What would we do in red here to get Q? I would multiply them by C, correct? So I would go C, C, cancel, and I would get Q equals C sine B. Everyone agrees? No matter what the number is. It would be C sine B. Yes? What would it be over here? B sine C. Correct? Everyone agrees? Now, you people being the intelligent young people that you are, if this equals Q and this equals Q, then what do we know about C sine B and B sine C? They are equal. Agreed? Now, using algebra, which is our good friend, how would I get rid of this B? What would I do with that B? I would divide by B, and that would go away, correct? But if I do something one side, what do I got to do the other side? Divide by B. What about here? What would I do to get rid of that C? I'd divide by C, and what would happen to those C's? Cancel out. And what would I have to do over here? C. Sine B divided by B equals sine C divided by C. And if they're all the same triangle, what then obviously must be the case of sine A over A. Now, please notice I've written the sine law the other way around. Does it matter? Remember in the very first day we were doing trig, we talked about similar triangles? You can put the larger number on top in the numerator spot all the way along, as long as it's all the way along. So here, I could put the side in the numerator spot and the angle in the denominator, as long as I do it all the way. What I would not be allowed to do would be to say equals sine B over B. See how I reverse them? That is not okay. But as long as I keep the same order, it is. Does everybody understand? Now, come back to this question. Knowing what you know now and what you just proved, if I have angles here, 94, 68, what would this third angle be? $18. Nice subtracting. All right. If I have those three angles, then do I have values for there, there, and there? Right? Yes, I do. Oh, I lie. I'm sorry. Down here. Values for there, there, and there. Good call, Jess. Let's go. I know, it doesn't feel right. Everybody understand? Okay. And now, even though this doesn't have a 90 degree anywhere, we can do trig with it. Everybody cool? All right. Let's now apply what we just learned to this. In triangle ABC. So I'm going to draw a triangle ABC. Does it matter how I draw it? No. So I'm just going to go ABC. Everybody happy with that? Okay. Now, this says angle A is 40 degrees. So where must I put angle A right now? Right here, 40. Where would I put B is 75 degrees? 75 degrees. And what do I then know C? Yes, I do. What is angle C? Angle C equals what? And who breaks out the calculator, does a little subtraction for us? What? 65. Why? Right. Because 180 minus 75 minus 40 equals C. Everybody cool? Now, is this triangle drawn accurately? No, of course not, because you can quite plainly see I have drawn angle C as a smaller angle than angle A, yes? Right? So, can I use this triangle in actual, life measuring? No. Can I use it in trig? On paper? Sure I can, because I'm just using it there to help myself out, right? So, now, do I know this side? Is this little a, little b? This is little a, right? Yeah. Do I know this side? Yes. What is it? It's little c, but I actually have a value for it, don't I? It is 6. Do I know this side? Is little b. I want to calculate AC and BC. And I have no 90 degrees. But now I know the sine law, don't I? Right? What do I know? I know that A over sine A equals B over sine B equals C over sine C. Can I fill this in now? What is little a? Do I know? So what do I write there? A. Do I know sine of big A? What is it? Sine 40. Agreed? And that equals, do I know B? Little b. Do I know little b? No. So what do I write there? Little b. Do I know sine of b? It is sine 75, correct? Do I know little c? What is it? Over what? Excellent. Now I must solve 2 different equations, correct? I must solve this equation, and I will choose 2 different colors to do so. I must solve this. B over sine 75 equals 6 over sine 65. How do I solve that? Have we already done fraction equals fraction in this room? Yes, we have many times. What do I do? Again, I call your attention to your grade 5 algebra that you know. 3/8 equals x over 24. Cross multiply. What and what? What would I do here? Okay, let's pretend you don't know how to cross multiply. There's an x there. What's your job? Get x by itself. So what's wrong? What's wrong with x right now? It's being divided by 24. So how do I get rid of it? I multiply this side by 24, correct? Cancel, cancel. What do I do over here? Same thing. Multiply by 24. Is that a numerator or denominator? Numerator. So I would do 24 times what? 24 times 3. And then what? Divide by 8. Everybody cool? That's algebra. Now look back at the original question. You know that if I was doing algebra here, that at the end of it all, to get the right answer, I would have to do 24 times 3 divided by 8, correct? Look at that question. You see all the numbers there. What math do you do? 24 times 3 divided by 8, right? So now look here. Sine 75 times 6 divide by sine 65. And what do I get? No, of course you don't know. You can't do that in your head. You got to do that with your calculator. But we've already done trig with our calculator. What then is B? Yeah. Just like that would find me X here. Yeah. What is B? It is 6 sine 75 divided by sine 65. Now, I'm not telling you how to punch that into your calculator because everybody's calculator is different. So what's the answer? 6.4. I'm happy with that. So that means B equals 6.4. Everybody cool? It's exactly like doing it with regular numbers, and it's exactly like doing SOHCAHTOA. Because let's think about it for a sec. Isn't SOHCAHTOA this anyway? Right? Think about how we finished our SOHCAHTOA questions. Right? If we don't go to our calculator, this is how we wrote them out, right? 6 times 75 divided by 7. Right? We did that a lot. So everyone's cool? Now, we still know that, and I'll change color again, because this is where it's going to get weird. I'm going to come over to this nice blank white spot over here. I've got 6 over sine 65. And I know I've already done B, but now I got the A to worry about. So what's going in the numerator here? A. And what's the denominator? Sine 40 this time, correct? Do not go to your calculator because something weird's going to happen here. What do I do here? A equals 6 sine 40 divided by what? Sine 65. And what do I get? Now go to my calculator. 4.3. Now, let's stop and think for a second. We're going to leave it right there because right now you are believing that your calculator gave you the right answers. Correct? Everybody is happy, right? All this math makes perfect sense. Yes? All right. Now, let's do something to show you a way to check this. Four, 3, 5. 9-degree triangle, yes? What's the longest side? What's the biggest angle? 90. What do you notice about the longest side and the biggest angle? They're opposite from each other. Everybody cool? Okay. So, pink theta. What value would that be? You could use any of the trigs to find that, right? You choose. Somebody tell me what the value of pink theta is. Doesn't matter what you use, your choice. You can use sine, cos, or tan. I don't care. Are we ready? This should not be taking this long. 53. All right. Now, do I automatically know the other angle now? What is it? 37. Everybody agree? Okay. What do you notice about 37 compared to 53? It is smaller. What do you notice about 3 compared to 4? It is smaller. What has just happened? The biggest angle is across from the biggest side. The smallest angle is across from the smallest side. And the middle angle is across from the middle side. If it happens once in math, how often does it happen? Always. Now let us go back to our question here. Is the biggest angle across from the biggest side? Is the smallest angle across from the smallest side? is the middle angle across from the middle side. So did we do our math right? Yes. Is everybody cool? Now, the worst thing that kills us math teachers beyond anything is when you people don't take information you know and apply it into a different situation. You look at question 1 and you're like, I got it, and you kick its ass from here to Tallahassee. And then question 2 is the exact same concept. And you look at question 2 and you say, I know how to do it. I know. And we say, but it's the same as number 1. No, it's not. There's a number 2 by it. It's different. Is it? No, it's math class. If it happens once in math, how often does it happen? Always. So, in this triangle, A, B, C, A, B, C. What's the sine law? Lil A over sine big A equals Lil B over sine big B equals Lil C over sine big C. Right? Now, what happens if that triangle changes to this? Anything change? Nope. Okay. What if it changes to this? Lil Q, Lil S, Lil R. What if it changed to this? Would it matter? Of course not. So, let's look at question 2, where we are working right now. What is different? It's not ABC, it is what? DEF. So, let's draw it over here. Does it matter how I draw it? No. What do I know? What do I know? That's 35 degrees. What else do I know? What else do I know? Now, can I do the sine law? Of course I can. Why? What have I got? I've got big D and little d. So can I do the sine law? Okay. So little d over sine of big D equals what? Lil E, which is 12, over what? Sine big E. Can you solve that? Yes, you can. What do you do? Right. Where, I don't like calling it cross multiply because there's two things crossing here, yes? Where are we allowed to multiply? By now, I should hope you see this shortcut, but if not, we're going to do the long algebra way. What's the shortcut? You do know the shortcut because we just did it with 3, 8, x, and 24. No. No. 7. So we're going to do the long algebra way because because Austin said this. 7 sine E cross multiply must equal what? 12 sine 35, correct? Now, I need E by itself, yes? So what would have to happen here? I would have to divide by 7, correct? Right? So I am left with sine E equals 12 sine 35 divided by 7. Now, please look back at the original question and come up with your shortcut so you don't have to write all these steps. Please look at what happened. We did 12 times sine 35 divided by 7. 12 sine 35 divided by 7. Multiply where you have your pair, divide what's left over, which creates the fun little rhyme that I hate doing, but I'm going to do it anyway. Multiply the pair, divide the spare. Now, when you do this with your calculator, will you get the value of E? No! You will get sine E. So what must you do to get the value of E? Shift sign. So on your calculator, you are actually going to do shift sign, right? Bracket 12 sine 35 divided by 7, close brackets. Now, if you have a backwards calculator, this is excruciatingly difficult. You are going to reverse this. You are going to go 35 sine times 12 divided by 7. But all that needs to be in brackets. And you are going to get what for an answer? That got me the decimal. Yes? And then what do I need to do? Shift sign that. Now you can do it all in one step, but you don't have to. Shift sign of my answer, and I get 80 degrees. Is everybody cool? 1 second, Ekim. I'll get to you in a second. You haven't been here for 3 days. Is everybody cool? Get your calculator to here. If you have a backwards calculator, it is easier to get to the decimal first, then hit shift sign. Is everybody good? Is everybody okay? So this is now 80. Agreed? Everyone agree? All right. Now, Ekim, please watch this because maybe this will answer your next question. I also need this side, don't I? That's little f, yes? Do I now know what this value is? How? Right, so what is it? I love it when the subtraction stumps you. 65. So now what do I know? I know that little f divided by what? Sine 65 equals, can I use 80 and 12? Can I use 35 and 7? Sure, doesn't matter which one I use. I'm going to use 35 and 7 to keep the pattern going. Everybody cool? Now, if I did the long algebra way, I would have to cross multiply both of them, and I would get f sine 35 equals 7 sine 65, right? And then, since I want f by itself, what would I do? I would divide this by sine 35, divide this by sine 35, And I would get f equals 7 sine 65 divided by sine 35. Now, that's doing all the steps. Once you have done all the steps, once you have walked to grandma's house 1,000 times, can you start looking for shortcuts? Yes. So we've done this the long way. Let's look for a shortcut. Look back at the original question. I know at the end I have to do 7 times sine 65 and then divide by sine 35. So look up here. There's the 7 times 65, and there is the divide by sine 35. And you find you can do a shortcut by multiplying the pair and dividing what's left over. You don't have to. It will just save you time. And when you do that math, you find f equals what? Go to your calculator. 7 sine 65, I must close the brackets, divided by sine 35. And I get 11. Everybody cool? 11.1. So what will I write here? What is f? 11.1. And then I can check. Is my smallest angle across from my smallest side? Yes or no? 735. Yes. Is my biggest angle across from my biggest side? Yes. Is my middle-sized angle across from my middle side? So did we do our math right? Is everybody good? Going once. Going twice. Going thrice. All right. That's the sine law. Now, right down here, maybe you want to write in. To use SOHCAHTOA, what do I need? Either, what do I need to do SOHCAHTOA? A side and an angle, or, that's the same thing, dude. 2 sides, right? So to use SOHCAHTOA, I need either A, 2 sides, or B, 1 angle and 1 side. To use sine law, what do I need? What did I have in both cases of doing sine law? An angle and its opposite side. Everybody good? Is that all I need? I need another what? I need another angle and any other side. Need an angle and its opposite side and one more of either. Everybody cool? Let me show you what I mean by that. 27, 18, and 14. Could I do sine law there? Yes, because there's my pair. I know this, don't I? Right? Because this is 180 minus 27 minus 18. This is little a, which goes with that. This is little b, which goes with that. Right? Can I do sine law there? No. I know a over sine 27 is a ratio, yes? Why can I do no trig? Because what do I compare that to? Nothing. Everybody cool? Hey, yeah? We're all good? Yeah? Okay. So, your work today, because sine law is that easy, is page 83. Now you will notice I have done something pretty cruel to you. Up until now, I have always shown you the answers, yes? Why didn't I? No, because in this one, you can check by
checking if the middle is the middle angle.
Yes. Excellent. Now, stop for a moment. Are you allowed to forget all the other stuff that you know? No. Here is what I mean by that. Does that have a sine value? It does, doesn't it? It's whatever this value is divided by that, right? Right? And when you do that on your calculator, and just give me a moment, let me do something here to do what I need to do. Hold up. Right? Everybody cool? So the sine of 47 is 731 over 1,000. Agreed? And if I go to my little calculator and I go shift sine 731 divided by 1,000, my calculator is going to tell me it's 47. Agreed? Everyone understand? Okay. Now, what if I had a triangle like this? There's my theta that I need to find. Everybody cool? Everyone agree? And I do some work with it, and I find that theta equals 47 degrees. All right? Now, this is 24, this is 38, and this is 102. Does that work? Why not? It doesn't add up to 180. So why would my calculator give me 47? Remember back 3 or 4 pages ago where we saw our calculator gives us reference angles? So it will tell me 47, but isn't theta of 133 also 0.731? So you have to use your brain. Everybody with me? You might, but you already know that. Why do you think I just told you that the biggest side is always across from the biggest angle? And why did I spend a whole class talking about how 2 different thetas can have the same sine value? She's not a fool. Don't be that way, Toby.
He's always like that. It really.
It's just hurtful.
It's knocks me down my self-esteem.
It's hurtful. But everybody, you see what I mean, right?
Yes.
If you get an impossible situation, stop and think about it. Right? Oh yeah. 47, there's another angle that has that same sine. It's 133. Does that work? Oh, it does? Okay. Everybody good? Go. Yep. So what's that first one, Jess? Just to remind everybody how easy it is. What are you going to hit in your calculator? You were right. Say it.
10 sine, well, like 10 times sine 35 divided by, or over, I don't know, sine 40. And it's not shift because you're getting the side.
There you go. See how easy it is? Now remember, if you have a backwards calculator, Sebastian, you want to find this decimal first. Don't even bother if you've got a shift sign. Okay? Everyone is good? Work. Finish the